Welcome back to our polynomials unit. Today we're going to be looking at dividing polynomials. We've reviewed multiplying, adding, subtracting polynomials. We introduced algebra tiles, which we've used for all of these. We've talked about what a polynomial is here. And we went through basic exponent laws and commutative rules and stuff like that in our pre-unit review. All that should be watched before dividing polynomials. We'll get into that unit right now. So dividing polynomials. Let's recall basic division here. So 12 divided by 3. So how many times does 3 fit in 12? That's what division means. How many times does this denominator, this number here, fit into 12? Or we can think about it as 3 sets of what make 12? So similar to our multiplication video, we're going to make a grid. Except this time, the grid's going to have some different pieces set up on the board. So we're going to set up our denominator. That's our 3 here. And we're going to place our product in. So how many sets of 3 fit? Well, let's see. We got 3, 6, 9, 12. So how many sets of 3 was that? It was 1, 2, 3, 4. That makes sense because, as you think of it as a puzzle, filling in the spot here, 4 times 3 gives us 12. Or 3 sets of 4 gives us 12. Find the missing pieces. So over here we have 2x squared plus 2x is being divided by x. So this is where we get into our polynomial expression being divided by a monomial. That's what this unit is going to be about here. So I'm going to set up my x, my denominator, and I'm also going to set up my product, right? How many x's fit in 2x squared plus 2x? It's weird to think about. We'll talk about some methods to get there. Here's one of them now. So we're going to see what missing pieces fill in the blocks here. So what needs to go here that would have given us this product? Just so you can see here. So we have x times x, right? X times x gives us x squared. X times x gives x squared. And then we have 1 times x and 1 times x, right? And we can take a look at it with our pen here. If we take the size of this block and the size of this block, it creates that square, right? So if you think about the square, make a little area around it, and you should express that length going up and down. So see it's smaller here, which makes an individual block. Let's try it again. So 3x squared being divided by, or plus 6x being divided by 3x. So there's my 3x, my denominator. I put it on the side. Remember, it doesn't matter which side you put it on. And there's my 3x squared plus 6x. Now notice I stacked everything so they're in an equal array. Now we're going to see what fits. Well, I have my x here. And what fits here? Well, another length of x is going to fit there. What fits here? Must be a 1. Must be a 1. Let's find out. Whoa. So x plus 2 is our answer. So how many 3x's fit into this? X plus 2 x's. 3 x's. Let's take a look at another problem. I'm going to show you a method to solve it without algebra tiles and with algebra tiles. So first we're going to set up our denominator. Then we're going to set up our product. All right, so what fits? Missing puzzle, right? So we take the lengths on this side here. Notice the same lengths are shared, right? I can draw and I'll just connect everything through. That's how I know I set it up nicely. And that's what fits in our puzzle. Now let's take a look at how we get to this answer without algebra tiles. So similar to multiplication, you can distribute division. So we are distributing this 2x to both terms. Both terms are being divided by 2x. So here's me distributing that 2x to both terms. Now, a lot of you won't have to do this step. I'm going to factor everything out so that I can show all the values that make 6 and all the x's that make x squared and so on. And then we're just going to cross out any terms or any values we see that will make 1. So like 2 divided by 2 is going to give us 1. X divided by x is going to give us 1. And 2x divided by 2x is going to give us 1. So in the end, I'm going to have 3 times 1 times x. So that's going to be 3 times 1 is 3. And then times x is going to be 3x. And then how many 2x's fit into 2x? Well, 1 does. Or if I cross everything out, there's going to be 1 left. So 1. Let's continue without algebra tiles. So here we have 3 examples I'm going to walk you through. You can pause the video if you'd like and see how you did. So first thing we're going to do is distribute the denominator. So I've split up my 2x between both terms. So now we're going to look at 5 divided by 2 and x squared divided by x. And then 8 divided by 2 and x divided by x. So I can split things up further to help the students that are struggling with these being so close together. You can actually split them all up and get a better visual of how to solve this problem. So 5 divided by 2 is 2.5, x squared divided by x is x, 8 divided by 2 is 4, and then x divided by x is going to be 1, right? So, and 1 times 4 is just 4, and that's why nothing changes there. That's why it's just a 4 showing up. Looking at this problem here, we'll distribute the 5m to both terms. So we have 80m squared divided by 5m minus 45m divided by 5m. I can divide the coefficients into variables. So 80 divided by 5, m squared divided by m, minus this term here, which is 45 divided by 5, m divided by m. So 80 divided by 5 is 16, m squared divided by m is going to be m. And then we have 45 divided by 5 is 9, and m divided by m is 1. Right? That's why it just becomes a 9. This next problem here, it's not stacked, but it's still the same thing. We have 30x squared plus 6x divided by negative 3x. So I stacked it here for you. And then we have 30 divided by negative 3. So how many negative 3's fit into 30? We're going to say negative 10 of those. How many x's fit in x squared? We can have, how x squared divided by x here is going to just give you 1x. Negative 3 divided by 6 and x divided by x. Right? How many x's fit into this x? Well, 1 does. So negative 10x minus 2. So now we have added some more terms to our problems, plus some more variables here. So you can pause the video, give the problem a try. I'll show you the solution and the steps in the process here. Okay, so distributing our terms, right? Our denominator is now attached to each term. Okay, and then we can start simplifying. So I knocked out this x here. I went 10 divided by 2, which gave us 5. I went 8 divided by 2, which gave us 4. Knocked out one of the x's there, right? Because there's 2 x's. And I just knocked one of them out. And then 2x divided by 2x. Well, how many 2x's fit into 2x? 1. There's our solution. This one here. So negative 14mc divided by negative 4m. We can knock out the m there. And we take a look at negative 14 divided by negative 4. That's going to become a positive answer. We have m squared divided by m. We can knock that out. Then how many times does negative 4 fit into 10? Then we have 50 divided by negative 4 and m divided by m. So there's our answer here. Excellent job. And then I'm going to give you a classic problem here. You're going to be given an area and a side length, and you need to figure out what the missing side length is. So the area of the rectangle and one side length is given. Write an expression for the bolded missing side length. So here's our bolded missing side length. Give you some hints here in case you forgot. Length times width for area, right? And then if you isolate area or length here, it'll become area divided by width. So that's what we're going to do. We're going to take our area right here and divide it by our width. So now we're going to split up our terms. And we say how many times does 1.5 fit into 3? And we have m dividing our m squared. How many times does 1.5 fit into 9? And we have m divided by n, so we can knock that out. And that gives us a beautiful 2m plus 6. That concludes dividing polynomials, short and sweet. Next is our big questions. Thank you for watching.